I think we are now online. Am I right? It's written in the YouTube. We are online.
Yes.
Dear Sama, can I start? Okay. Dear Wolfram ELSNER, thanks a lot for accepting to be keynote speaker for the event, International Symposium on Economics Thoughts. And in this session, Wolfram ELSNER from University of Bremen will give speech for the topic collapse, institutions, decline, and break down its endogeneity and asymmetric Vis-á-Vis emergency and conceptual framework. Thanks a lot, Professor, for joining this event, and we are waiting for your speech. And around, like, as far as I know, it will be around 45 minutes.
Yes.
And I will check time, and floor is yours.
Yeah, thank you very much. Great honor for me to give one of the keynotes here this morning. There was a little mess up, as you see, with the title. We had discussed two titles, and my thought went into another direction than my partner from the organizers group went. So I have changed a little bit in fact, the title didn't fit to the abstract, as you probably have seen if you read the abstract. So this is the correct title that we had originally agreed on. So I'm a bit more, I'm not talking about the collapse model and conception that I've worked. You can read that in the Journal of Economic Issues right now in the current issue that appeared in March. But this is something where I thought fits better to your conference. It's about the history of economic thought, and I look into complexity economics and into the roots of it embedded in history of economic thought. So my title is History of Economic Thought, Embedding the Roots of Modern Complexity Economics. I look into the ideas of complex systems, the theoretical mechanisms that are embedded in the history of economic thought, and into some complexity policies. Okay, so I hope this will not make collapse your conference, but is more at the core of what you're doing here in this conference in the next 3 days. Okay, in history of thought. So the structure is I look at economic complexity in a nutshell. It's about so-called non-ergodic evolutionary development or dynamics, and it's about emergent properties, to pick two of the main characteristics of economic complexity. Then I look into the history of economic thought for some roots of the so-called self-organization mechanisms that have been rooted there, because a new development like complexity economics in the last 30 years or so doesn't fall from the sky simply. It has, of course, its roots in history of economic thought. And as history of economic thought is much neglected in research and teaching in economics nowadays worldwide, there's a lot of loss of ideas. And I do a little effort to make you aware that there is something to find in the history of economic thought, even about complex thinking. I have a textbook out, The Microeconomics of Complex Economies at Elsevier, and there we have a whole huge chapter on the roots of complexity in history of economic thought. So then I pick a particular perspective, evolutionary institutional, which has always been, is more than 130 years old and has always been complex in a way. And I show you why and how. And then I go into some policy implications, if we have the time, and some conclusion. So complexity in a nutshell. And Dervis, please, you give me 5 minutes ahead when my time is running out, okay?
Yeah, no worries.
Okay, good, thank you. Now, in a complexity economics perspective, Old Greek is pleko, to weave, to play, to entwine. Economies are so-called complex adaptive systems, CAS. That means they are consisting of many and potentially and eventually heterogeneous components, aggregates, entities, whatever. In our case, usually agents, be it firm agents or be it individual humans. They are interacting with each other and adapting to each other and to local and global informational conditions of the system. So they can adapt to their local, to the information they get from their local environment, but also they might get, depending on their informational status and on the informational flows in the systems, they might, of course, get some information from the global level, from the macro level, so or the aggregate level, the system level, and they may adapt to that as well. So in a non-trivial, they do that in a non-trivial and somehow systematic way, often with destabilizing a positive cumulative feedback loops of behavior, which immediately results in all kinds of non-linearities, which makes the system analysis and the system as such immediately very complex, non-linearities. While we have it in the standard textbook, a model of the market of a static partial market equilibrium, we have only linearities. Basically, systemic linearity behavior, I would say. Of course, the demand and supply curves may be nonlinear, but they have at least a static, unique equilibrium. So this is completely different here. So with nonlinearities and positive, cumulative, positive feedback loops and systematic interactions, in some ways, systematic interactions, agents are in some ways reacting to each other, and repeatedly so, there is a number of so-called emergent properties, that is distributional structures, behavioral structures, institutional structures that cannot be traced back to the properties of the individual agents. So the individual agents have their properties and their behavior has the properties, but something emerges out of that that you cannot linearly and determinately trace back to that micro level. That is the very content and definition of the term, of the conception of emergence. Others have called it morphogenesis, so the genesis of some structure. The sociologist Niklas Luhmann has called it autopoiesis, so endogenous creation of something. And this is, in fact, indicative of what we call a self-organization mechanisms, as termed by many, Stuart Kaufman already in the early 90s, Melanie Mitchell, and others. And these self-organization mechanisms might sound positive, something, you know, we organize without knowing and without willing to do so. We organize some order, but this order could be good or bad. So self-organization sounds good, but it is not meant. It is value in terms of valuation and estimation. It is quite neutral. That is important. So this is an emergent of structures from the bottom up. But not only in the system, there's not only bottom up, of course, motion, but also a subsequent, if the structure is there, it feeds back down to the from a meso or a macro level, whatever that is. Then I will get back to that. It feeds back down to the micro level of the individual agents and their interactions. So it is a reconstitutive downward effect in the sense that if it feeds back down, it will change behaviors, information, rationales of the individual agents at the micro level and their interactions. So you see, we have a micro, a meso and macro levels, and the meso is introduced here to be determined, of course, I've written and published a lot of meso things, because meso is the particular level of evolutionary institutional economics and complexity economics, because not at a huge macro level, not at a national or global level, things emerge, but at meso levels in local, regional, professional group cultures. So the culture emerges typically at a meso level, where people still know each other or know someone who knows someone, and are interacting and feeling somehow the feedback of the interaction through the others, etc., etc. So meso emerges here as a particular theoretically important level. We talk about localities, we talk about regions, we talk about local cultures, we talk about firm clusters or agglomerations or networks, etc. So that is why I define a multi-level system here: micro, meso, macro. And for the explanation of such a complexity, a so-called generative social sciences, a social science from the bottom up, as the famous book of Epstein and Extel has called it, and a radical remaking of economics, as Beinhocker has called it. These are the books: Artificial Societies, Epstein, Extel, with the subtitle of Social Science from the Bottom Up and the Origin of Wealth by Eric Beinhocker, and the Evolution, Complexity, and the Radical Remaking of Economics, which is, of course, what is going on in complexity economics since 30, 40 years now. All right, complex systems then generate typical system properties, even relatively simple initial givens, very simple behavioral rules at the micro level. If people behave somewhere and search, etc., and react to each other, generates already often extremely complex system dynamics, as you simply can see in the traditional prototype and example of the so-called logistics map. You see very simple, a simple initial a logistics equation, and if you run it after the parameter, the one parameter therein only, then you see huge complexity emerging with phase transitions, tipping points, and so on, and chaos, etc. So there are some extreme idiosyncrasies. That means marginal initial parameter changes may have huge accumulative effects through positive feedback loops, so-called butterfly effects, bifurcations, phase transitions, as we all see in the logistics maps. If you Google it, if you probably know it. If you don't know it, just you Google it on the internet, and you see it running there. So the famous thing, history matters. That is nothing else than the conception of path dependence. Not history of thought matters, but history of a system also matters. And that implies another thing, that so-called improbable, or usually expected improbable, unexpected, surprising, sometimes radical new, in terms of innovation, radical new things, events, and motions may occur. The famous black swans that we are speaking of since 2008, since the great financial crisis. So empirical system states occur with a different distribution than theoretically predicted. So if we look at a system and consider it a mechanic system, then we would say, okay, there's a lever, up, down, up, down, up, down, and we know each possible status that system, up, down, the mechanical system may assume. But in reality, in empirical long-term series, we see that the system does not do that. It is rather non-ergodic. Complex systems are non-ergodic in the sense that the distribution of theoretically determined statuses of the system is not identical with the distribution of the empirical statuses that the system in reality can assume. So in terms of time series, we call it non-stationarity. Also, the opposite may hold. Strongly rigid patterns, sometimes the system may also run into a point where it is rigid and stands. So we call it attractors. With phases of stasis, the system absorbs all kinds of changes. We may call it resilience, we may call it homeostasis, we may call it equifinality. Also, sometimes the hysteresis effect from medicine or a ratchet effect is working. So the reason for something is fallen away, fallen off, is off, but the system still stands in that status. Okay, so all kinds of things appear here. In all, volatility of the system widely varies over time, and it is often hard to predict even in the short run, particularly as complex systems usually are between frozen order, as Kaufman put it, and gaseous randomness. Don Farmer had a same, nearly the same formulation, or Kaufman complexity varies at the edge of chaos, which is explainable through the simple consideration. If systems are too often running into phase transitions and crises, they will die off. Okay, they will be selected off. But on the other hand, if systems are far off that edge of chaos and are too simplistic and not complex enough, then they will die off as well. So you see those systems that remain and are in working and moving and in competition with each other, perhaps they are more or less moving back and forth around this situation, edge of chaos. So what do human social agents do with their intentionality? They have some intentionality. What do they do in such systems? Well, they strive, of course, for reducing uncertainty and perceived complexity. They try to reduce the turbulence that they perceive of their decision situation. They search, they learn, they strategize in order to simplify the decision structure of their environment. They of course realize that they sooner or later they might get a feeling that they are facing intricate problems with each other, and they try to solve these intricate problems in order to improve their outcomes. Just the old idea of we want to improve. We don't want to maximize because we don't know what it is. And we cannot, but we want to improve. We want to move upwards, never knowing whether we are going up the Mount Everest or a little hill in our garden. So, for instance, ubiquitous social dilemma problems, collective good problems, commons problems, but also more simple coordination problems, which are quite simple, but not that simple, in fact, to solve. Because there have been different solutions for simple coordination problems. Do we drive on the right side or on the left side of the street? Do we stop with red or with green? So this is all, 100 kilometers, 200 kilometers from here, from my place here in northern Germany, is England. They have found in history, in an evolutionary process, the opposite solution, driving on the left side of the street. Okay, so even coordination problems are not that simplistic. So agents adapt to conditions and adapt their behavior to their relatively limited cognitive capacity. They have huge inflow of information, often too much, but they are boundedly rational because their imagination capacity is huge, but their calculation capacity and their quick, immediate calculation capacity is very limited. So that is why Herbert Simon came up to the conception of bounded rationality and the resulting behavior of satisficing. We are satisfied as long as we make it to improve a bit, but we would also be satisfied if we would stand up on a little hill, on the top of a hill, rather than standing on the top of the Mount Everest. So what can individuals effect then this way? Well, some self-organization in order to try to learn, to strategize in order to coordinate in coordination problems, or to cooperate in solving the social dilemma problems. So we make a distinction between coordination problems in game theory, evolutionary game theory, coordination problems and social dilemma problems. And the solution for the coordination game is a coordinating behavior, a learned coordination, social rule. And the solution of social dilemma problems is active cooperation, what we call the learned behavior of a social institution. So that's what is said here. But also accept institutions, behavioral structures that sooner or later get a general acknowledgement and approval, and followed by a critical minimum mass of people, and then get a social validity. There are other structures that emerge, such as distributional structures mainly. Sorry. So I get to the distributional structures as an example soon. And both can, of course, as said, good or bad. As Veblen put it, Thorstein Veblen, the founder of modern original evolutionary institutional economics, he said, look, there are different motivations within us. We are opportunistic. We want to be socially acknowledged and approved, but also we are egoistic and selfish, and it depends how we depends much on the conditions, how we in fact behave. And so that means that there can be instrumental problem solving, social dilemma problems solving institutions, or ceremonial, just status and power differential institutions where the motivation is, I want to be better than you, I want to make a distinction to you, I want to be above you, etc. I want to demonstrate that I'm a good, rich, powerful guy, etc. Rather than solving problems with each other, the instrumental side. So in either way, social rules and institutions, social institutions emerging, generate some forms of stability, which is, again, good or bad, can be good or bad, sometimes rigidity, but also in between very volatile phases. So as the example, as announced, persistent structures. Look at the empirical properties of complex systems. They usually display right-skewed statistical distributions with so-called heavy tails. We have persistent fat tail distributions of income and wealth. Pareto did that already. City sizes, the famous Zipf law, firm sizes, Gibras law. Herbert Simon did a lot on that. Asset prices and returns, price changes in the financial sector. Mandelbrot did a lot about that. Here's Pareto, here's Benoit Mandelbrot. And these fat tails distributions occur everywhere in many natural as well as socioeconomic systems. Nodes in the centrality of the World Wide Web are fat tail distributed. You have very few huge, big, powerful nodes with many relations and cliques, etc. You have very many with medium and some with very little cliques. Scientific citations networks have that property. The occurrence of words, even in our languages, has a fat tail distribution, but also in natural sciences, the natural sizes of natural forest patches, depending on the self-organization mechanism of fires, lightnings and fires, etc. So if a patch gets very large, the probability that it is caught by a lightning and catches fire and burns down is larger as well. So that means you have very little huge patches and a mass of smaller ones. and the famous Per Bach and others on the self-organized criticality is about exactly that. The experiment of the sand pile avalanches. You have a sand pile, and you drop sand corns from above continuously, and then it piles up and gets very steep, and then you have an avalanche, and it gets to its so-called equilibrium status again, but piles up again, etc. And the avalanches themselves, the size of the avalanches is fat-tail distributed. So that means that large system motions and large crises occur with relatively high probability compared to what we usually have in financial sector models, etc. The normal distribution does not even know these events. So sometimes normal distributions are adequate, like body sizes, for instance, are normally distributed. Everywhere where you can apply the so-called Brownian motions, you can apply normal distributions, but usually in complex systems we have heavy-tailed distributions, so-called Pareto distributions, and that tail makes a huge difference. If a tail risk far away on the right hand of the distribution graph, if that tail risk, a huge agent, for instance, a huge corporation, a huge bank, gets into a crisis, the entire system will be heavily affected. So here you have the fat tail distribution, and the systemic relevant entities, agents are here. And this is completely, this area is completely ignored in a Gaussian distribution. So in a Gaussian distribution, this would be virtually zero and very probably, if not excluded, to occur at all, in fact, ignored. But in fact, there is the location of the big tail risks. So in all, this implies a theoretical research program for us. We have to look for the respective theoretical self-organization mechanisms that in fact come up generating such a distribution. What is it? Why and how do we do this in human societies? So here's something older from the 40s, 48. Physicist and philosopher Warren Weaver did that thing. We do not talk about simple systems, of course. We do not talk about non-organized complexity, where there's an averaging out, So in a gas, in a container, you have some complexity in the sense that there are many, many agents interacting, molecules, but you can neglect their interactions because it averages it out. So if you take out one molecule, you know them all. If you take out two molecules and look at their interactions, you know all two by two interactions. If you take three out, you know all three by three interactions. What we talk about is self-organized complexity, or organized complexity, as he called it then. So the interactions do not smooth each other out. They do not go into an equilibrium. They do not run into a static something. But they accumulate, they feed back, and they are in a constant motion back and forth to attractors and phase transitions. So we call it self-organization. Now, in search of self-organization, in history of thought, very sorry, I'm talking to Turkish people. I have to take an ancient Greek example, but at that time, I think the history of thought was still European dominated. I'm pretty sure that I missed a lot of Eastern and Turkish culture thinkers and Islamic thinkers, etc., etc. but I know a little bit of my own learned history of thought. And here's Aristotle, 2,400 years ago, the founder of economics, of the very term of economics, oikonomia. It was oikos and nomia, so the government of the house. In fact, don't tell the business studies colleagues that economics started as business studies in the term after Aristotle. So the oikos is the big house, the huge farm with some hundred of slaves working on it, a lot of family, clan, etc. And the polis is the antidote of that, is the city system. So the micro is a micro-macro system, components, two components, and there is a system in Aristotle's understanding, because the levels are interacting. In metaphysics, he said, the totality is not a mere heap, not a mere sum, he means, but the whole is something besides the parts. So he had an understanding of a complex multi-level system interacting. If we look at this, you can of course not read it. This is a kind of brain map of where we are. All kinds of people in the history of economic thought, starting with Smith, and here's Darwin. He comes in. He's not an economist, of course. Marx. Here's Malthus. Then the evolutionary institutional tradition, Veblen, Commons, Galbraith, Myrdal. Here we have Boulding, Georgescu, Rögen. Here we have the physicist Nobel laureate Prigogine, who is of course not an economist as well, etc. Nelson Winter, you see here. So and Schumpeter, of course. So we have all the evolutionary history of thought on that side, all ending up in evolutionary economics, institutional economics, and in terms of modern methodology in agent-based computational simulation. And we have also with Malthus and with von Neumann Morgenstern, we have game theory. With Keynes, we have very complex systems, and Goodwin, evolutionary macro. And it all ends up nowadays in agent-based macro models as well. And here's evolutionary game theory. I'm looking, Schelling here, of course. I come back to Schelling and Extel, Axelrod, etc. So, of course, we have Hayek as well, Marshall here. More the mainstream neoclassical side, but the evolutionary neoclassical side, Austrian economics, and they end up as well. So we are covering not the entire map in always the same way, but we are located more or less in a history of thought at certain broad strands over the history of thought. Okay, in modern times, we had this person, Bernard de Mondeville, French, and the famous Fable of the Bees. The Fable of the Bees with the characteristic subtitle, so to speak, Private Vices, Public Benefits. Well, from private vices, he said there are positive unintended consequences into the general public, and the general public benefits. So he's arguing as one of the defenders of old feudal classes, and he said, let the feudal classes leave their money and let they make parties all day and all night, let they eat and drink and spend their money. As long as they do, all the others profit. The servants get their incomes, they spend money, the traders and the craftsmen, they will all profit from that. So the general public profits. So it's a first idea, or one of the first ideas, of a trickle-down mechanism, where something trickles down throughout society. We have that trickle down in neoliberalism as well, very modern, Bernard de Mondeville. So let the rich get richer, neoliberalism said, because they spend their money, and everyone, and they will invest, of course, not only speculate, they will perhaps really invest their money, which they hardly don't do. But anyway, it will trickle down and all will benefit from that. Positive unintended consequences from individual vice, which is a very modern idea. This person, Adam Smith, he said he has a chapter on Mondeville, and he said, no, 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 a society doesn't work that way. It doesn't work well and properly that way, as you say, as he says, as Mondeville says. Um, uh, there is a necessary process to accommodate between our selfish and our social approval impulses, or strands in our potential behavior, and we need to enter a social interaction process and a learning process, and we need to develop, rather than an immediate selfish impulse, we need to develop an institutionally moderated egoism, what he calls prudence. So institutionalized prudent behavior only under these conditions, that no one ever immediately goes after his selfish impulses, which would be something like being non-cultural human, you know. So he says basically the cultural, the human enculturation process leads us to ideally to develop some prudent, institutional prudent behavior. That is important, and all the theme, more or less, in his theory of moral sentiments, which is the prior publication to his Wealth of Nations. So, and he says only after such social process, positive unintended consequences may occur. And then if the market is properly regulated, as he puts it in the Wealth of Nations, for long, all Wealth of Nations is more or less all about how the market is to be regulated, then positive unintended consequences may occur, and then they may promote an end which was not part, the agent may promote an end which was not part of his intention. So then only positive unintended consequences may occur from institutionalized individual prudence. So I go into history of economic thought more, and focus a bit on evolutionary institutional perspectives. The forerunner is probably Malthus, population periodically adapting to the different dynamics of the food conditions. Food conditions, he said, move linearly, while population develops exponentially. So you have a kind of cyclical overpopulation, underpopulation, etc. So we know that from the modern Lotka-Volterra model type of predator-prey systems. Darwin, not an economist, of course, but the person who introduced so-called phylogeny, population thinking in interacting populations, in different differentiated niche systems, and ever-changing social ecologies. So everyone changes, everyone adapts, and the social ecology of each individual and each species changes all the time, because everyone adapts and so on. So here's the famous evolutionary mechanisms of variation generation, selection, and retention of properties and characteristics. Nowadays, we call it, or it is called, Richard Dawkins, Stuart Kaufman, rugged and moving fitness surfaces. So no way to determine one static equilibrium or even a dynamic equilibrium, nothing like that. The fitness surface is rugged all the time. So you don't know exactly where you are, on which hill you stand, on the absolute top or on a little hill only, but at the same time this is moving. So a strategy that was correct in the last period and very successful may be very unsuccessful in the next period, of course, because the social ecology has changed. Marx was very immediately enthusiastic about Darwin's book, and he sent Darwin a copy of his volume one of the Capital, and he wrote in it that what Darwin had developed for for natural science, for biology, is the same what he, Marx, had developed for social sciences and for society. So Darwin immediately, Marx immediately realized that the epochal turn of sciences was into phylogeny, so into population sciences. In historical time, in dialectic motions like this one, predator-prey, you can mirror that as a dialectic, sorry. So nowadays, more recently in the 90s, Stephen Gould and Richard Lewontin, very famous evolutionary biologists, have taken even the Marxian dialectic to apply in their biological research. And you know, of course, Alfred Marshall, where the firm agglomeration is a complex adaptive system, because there's something emerging in a firm agglomeration in any technological park or whatever nowadays, where something emergent. It has been analyzed with the Silicon Valley, but with many other clusters, regional and local clusters as well. That there's something emerging, some new quality in the system, in the regional system. So, as an example, Marshall had said, information is in the air. So something is some collective knowledge. You know, I was working for some month at least in the Silicon Valley once, and I was surprised seeing at lunchtime where people come out in the sun and sit in the restaurants, and people from different companies gave each other little papers, and I listened a bit. Next table, they said, "Yeah, look, this is the solution that we found. Have a look at it, and let me know what you think of it." And I looked at it. Incidentally, I saw a top secret as a print on that paper, but he gave it to him. You know, so there's something, people are interacting and exchanging information. And the famous citation from Marshall, the Mecca of the economist lies in economic biology. Now, this person is Thorstein Veblen, the founder of original evolutionary institutional economics. And in 1989, after 30 years of 40 years, no, 35 years or so, after Darwin asked, why is economics still not an evolutionary science? And 1899, he made his famous theory of the leisure class, a study of institutions. Quarterly Journal of Economics in the why is economics not an evolutionary science, and the theory of the leisure class. Now he says there are broad behavioral possibilities that we have. We can do this. We can be a bad animal, and we can be very good social animals. And that depends on, because we have two different dimensions, at least, predatory instincts, he calls it, and social instincts. And that much refers to Adam Smith starting point. And he says in empirical societies, we have more the predatory size because of our history. There's a more the predatory size, the side of us in the forehand. And with predatory self-organization empirically dominating, we always engage in individuous distinction and conspicuous consumption, and we want to be better than our own social layer. we make a distinction to our own social layer. We make conspicuous consumption. Look, I have the bigger car than you. I have the bigger house, etc., etc. But we do emulate with upper layers. Yeah.
Just 5 minutes. It's
5 minutes.
45 minutes.
Yeah. Okay.
That's I want to inform you. Thanks a lot.
Yeah. Yes. Yes. Good. Thank you. So it's a struggle for social position, and you see here a trickle-down mechanism again down into negative unintended consequences, because we all behave more or less uniform and herd-wise. Emulating the upper classes. So quickly, Myrdal was one of the famous complexity guys, without using the term, using the circular cumulative causation with mostly negative unintended consequences. Herbert Simon, of course, had started with the heavy-tailed firm size distribution, and then worked forward to see how it comes up and how it came up, and determined the emergence of complex systems and the structure and the architecture of complex systems and the self-organizing mechanisms. A simple example: Thomas Schelling, Nobel Prize laureate, models of segregation. Simple model of an American city where no one is really racist, but they have just a simple rule: as soon as I am in the minority, I will move off. As soon as my race is at 49% or lower, I move off. Okay, so sounds very simple rule, but in the end, he shows it leads to a huge, strict residential segregation, negative unintended consequences. There would be more. So I come to end and leave the entire, I will leave the entire policy part out. Today, it is said self-organization mechanisms is simply called, with Barabasi Albert, for instance, one of the famous complexity persons, they call it the rich get richer, or preferential attachment. What do? We look, we go to those who have already many relations, and we attach another relation to them, and we cite those who are already been cited a lot. Veblen would call it a ceremonial institution. Applications in the financial sector, the black swan events, the big repeating big crisis, repeated phase transitions. I mentioned the self-organized criticality. Here, Benoit Mandelbrot again, and here Taleb, the black swan, the impact of the highly improbable. So I drop over the entire policy thing. You can imagine that from this there is a huge complexity policy structure or complexity policy conception emerging, particularly when we start with Axelrod, for instance, and the repeated evolutionary game theory and solving complex social dilemma problems, for instance. You have immediately a completely different structural approach to policy. You can read it if you like. I have a lot of papers published in several journals and books on the policy implications of complexity economics. But I'll skip over that and come to my conclusion. Modern complexity economics, and not only modern complexity economics, but modern economics in total. My habilitation thesis in Germany, we have the habilitation 5, 6, 7 years after the promotion in order to be able to become a professor. And my habilitation thesis was published in 1986. And that was a comparison between classical, Smithian, and original institutional evolutionary economics and institutional economics, and the property right, the new institutional Coasian Williamson strand. And I made a model of the development of the of economics as a discipline, and it is such that, like in a Kuhnian-Lakatorsian sense, it is always, there are scientific revolutions, but we are multi-paradigmatic discipline, because we cannot measure and select the different paradigms in economics out against each other. So that means if we process forward, neoclassical mainstream, for instance, has a lot of losses against the rich history of economic thought that we have. So we have to make a recurse to earlier parts. So, and this is where we end up here as well. Modern economics, particularly in my case, complexity economics, may build on a history of economic thought, much of which got lost, and a stock of theoretical mechanisms already rooted in the history of economic thought and as anticipated therein, in order to analyze today's empirical complex systems in a modern statistical computational perspective, in order to simulate and evaluate realistic alternative policy measures. And this is what the last bullet point is, what I left out here. But if you're interested in that, just write me or Google after me. So, for a better world. So it's nothing less than what we want to be. As the economic classics started off, we are a discipline in the end that wants to make a better world. So if I have half a minute, then I tell you this little joke. So the real deep philosophy of complex process, social institutions, and true uncertainty is this. Two economics students after the class, okay? They meet outside the classroom, and the left one here is the philosopher. He starts philosophizing to the others. Says, sometimes I'm shocked to realize how many options I have. The other one doesn't understand. What is he talking about? Oh, and he continues, like at any moment in any conversation, I could just punch the person I was talking to. And all these, and he's a really evolutionary guy. He has got my class, you know. These potentially life-changing events would unfold, a true evolutionary economist. And he continues, it's only my mental rules that stop me from punching you or stripping naked or getting on a plane to Fiji. Sure, rules have reasons, but shouldn't you exercise that freedom at least once before you die? Oops. Now the other one has got it. Wham! He punches him. Okay, now the philosopher at the bottom says, okay, I should have seen that coming. And now the other one proves to be the real philosopher. And he says the simple but very, very, very true words, but you couldn't. That's the beauty. Okay, thank you.
Thanks a lot, dear Wolfram ELSNER, for your great speech, and it was an honor for me also being chair for the session. Thanks a lot. I think maybe the hosts going to inform us. I think we are stopping at this point, and as far as I know, we are not taking, questions. I have to check YouTube channel maybe. I think we are stopping at this point. Thanks a lot.
Thank you
for your speech, and hope to see you one day after COVID if I come Bremen. Even my son always is watching the Bremen musicians cartoon, and he said one day bring to Bremen.
Good. Okay, thank you. I hope to be someday in Istanbul again with EP. We every now and then have our annual conference with the European Evolutionary.